Assalamu alaikum. My name is Fahrish Tabassum. My ID is MS1604000429. I'm going to present for the subject of Advanced Algorithm Analysis and Design. Code is CS702. Topic which I have selected is an overview on linear programming. So first of all, let me tell you about what is linear programming. We say it as LP also, linear programming, or we say it as linear optimization. It is a method to achieve the best outcome, like in terms of maximum profit or lower cost in mathematical model whose requirements are represented by linear relationships. So linear programming, it is basically a special case of mathematical programming or mathematical optimization. It can also be defined as a problem of maximizing or minimizing any linear function with subject to any linear constraints, and the constraints may be like equality or inequality. Some example is I have given. For example, if we have example that x1 and x2, like find two numbers x1 and x2 that maximize the sum of x1 plus x2, subject to the constraints of x1 greater than equal to 0 and x2 greater than equal to 0. So with all these things, we like come up with different constraints. All these constraints can be inequalities and or equalities with different kind of constraints can work there. And as a result of this constraints, we find out our optimized result. This optimized result we are finding out with the help of applying some linear function on these variables. So different constraints I have applied. The first two constraints, x1 greater than equal to 0 and x2 greater than equal to 0, they are kind of a special constraints. We say them as non-negativity constraints, and they are often found in linear programming problems. The other constraints, they are called as main constraints, the function to be maximized or minimized, and they are called as objective function. So from here we find out two kind of functions, one kind of an objective function, and here when we are finding the constraints, we say main constraints and non-negativity constraints. So here, as we are working with the two variables, we can solve this problem by graphing the set of points. We can graph them. We can make a kind of a plane that satisfies these constraints or set of constraints, and then we can find out which point or in this graph maximize the value of any objective function. So each equality constraint is satisfied by half plane points, and the constraint set is intersection of the half of the other planes. In the present example, like we have given constraints where we plotted these points in the form of a graph, and we said that this shaded area, this is satisfying all constraints, means this is our optimal area, and here from among this area we find out our optimal point. So means we solve this problem with the help of linear programming, that we said that this point is going to give us the maximum outcome in terms of satisfying the constraints. When we talk about linear programming, we talk about duality also. What is duality? Every linear programming problem, this referred to as a primal problem, it can be converted into a dual problem. Dual problem which provides an upper bound to the optimum value of the primal problem. So we can find out what can be the upper value, till which value it can go, what is the upper bound for us. So here again we discussed one example that in some equation, the maximized value of it, the minimized value of it, and how we can solve it. We solve it with the help of duality. Then for this we try to design the model for linear programming. For this model, there are some properties and there are some requirements, like there is a well-defined function of objective function, there are constraints on amount, then alternative actions will be there, then non-negative interrelated decision variables should exist, and supply of limited resources also should exist for designing any model for linear programming. So decision variables, these are mathematical symbols which indicates the level of business activity. Objective functions, these are mathematical description of relationships between the company goals in terms of variable solutions. The functions will be either maximized or they will be minimized. Constraints like working environment for enterprise requirements or limitations like expressed as a linear relationship between the variable solutions. Then parameters can be there like in terms of numerical efficiency and constant, which are used in objective functions and constraints, so they work as a parameter. Then how we are going to formulate this model? There are 3 steps which we discussed. That step 1, it clearly defined the decision variable. Second step, this define the objective function. And third step, formulate the constraints. These are the 3 steps for formulating any model for linear programming. Then for making this model, we keep in mind some assumptions also. What are the assumptions? First assumption is proportionality ratio, that rate of change or slope of objective function and constant algebraic equation. This is that ratio. And then additivity, like equation must be function, and objective limitation of the term additions should be keep in our mind. As like proportionality ratio, this also keep in our mind. That slope, always we should keep in our mind that this slope either remains constant or it should have some kind of a constant value. It should not go like in much variability. These kind of assumptions we keep in our mind. Similarly, divisibility, like variable resolution can vary any fractional value, or it can be constant or not truth. Is all these things we should keep in our mind. Then certainty, like assumes that the value of all model parameters are non-probability determined. So this is certainty, that how they are like how they can be certain or how they cannot be certain. Then there are some characteristics for linear programming, like the need of an alternate action policy. Decision making is represented by decision variables in the model. Problem includes a goal that the decision maker wants to achieve through the objective function. Existence of restriction, which we talk as a risk constraints, that can limit our extent to which the objectives are achieved. Goals and constraints must be defined by linear programming, a linear mathematical function. And then we have defined this model, that a linear representation of linear programming model can be given as maximize or minimize as a kind of some function, like z is equal to p1 x1 plus p2 x2 till pn xn, with subject to constraints. Like constraints, for example, w11 x1 plus w12 x2 till w1n plus xn less than equal to or equal to for greater than equal to w1. Similarly for w2 we define, similarly for wm we define. So no negativity constraints are xi greater than equal to 0, where I can range from 1 to maximum n values. For this linear programming, there are different kind of algorithms which are working. Simplex algorithm is most popular one among other algorithms. It almost introduced in 1947, which solve linear programming problem by constructing a feasible solution at a vertex of polytope. This polytope is a kind of a graph. In this polytope, it takes the path of the edges of polytope to vertices with non-decreasing value of the objective function until we achieve any optimal value. So in many practical problems, stalling occurs. Like many pivots are moved with no increase in the objective function. In rare practical problems, a usual version of the simplex algorithm may actually cycle. Otherwise, we don't find cycling. To avoid cycles, researchers develop new pivoting rules also. And with the help of some kind of a graph, this model we are achieving. So this is quite efficient. This simplex algorithm is quite efficient, and it can guarantee to find the global optimal value if certain precautions are being taken. Otherwise, this simplex algorithm has poor worst case behavior. In worst case, it is not reacting as it should react. Other algorithms like crisscross algorithm is there, interior point algorithm is there, ellipsoid algorithm is there, and different kind of variables are working for linear programming. Like we have slack variables, surplus variables, artificial variables. Then how these variables are working for integer learning linear programming problem, and for mixed integer linear programming problems, how these variables are going to work. Then what are the advantages and disadvantages of linear programming? Like it helps to make the most of the factor of production. It improves the quality of decision making. It provides better tools to meet changing requirements. Then its areas is being discussed. That it provides area in management applications, industrial applications, and different miscellaneous applications, like for diet problems, agriculture, flight scheduling, facilitated location problems. It provides product mix problems, assembly line balancing, profit planning problems. Everywhere linear programming is being used. So overall, neural programming is used in many kind of areas where it is facilitating us through its features with the help of different kind of algorithms. Until now, we find simplest algorithm as the most efficient as compared to the other algorithms. Thank you very much.